What is NisGab? It's an acronym. It stands for New Input System Global Action Binding. And at the end of the day, what it is a simple code generation package that I wrote that takes the new input system, takes an input action map that you've created, and it automatically generates code bindings so that way you can statically bind to those events as well as enable and disable individual input action maps at will. So to make sure that you're set up, you need to make sure that this input settings asset is the one that's being used by your project. And you need a input actions asset. This is the default one that gets created with a project. You can use this one, you can use another one if you already have one in your project, or you could make a new one. This is the one that is going to work with this demo scene though. So in order to get this example working, just right click this and hit generate input action binding. And what that's going to do, you're going to see here in the script folder, you're going to have generated code. And in this example, you're going to see 3 classes that are generated. But in reality, it's going to be one class for every input action map. So if you have player, if you have UI, if you have vehicle, whatever, you're going to have one class for each of those, as well as this input event.cs class. And if we go into, say, the player input class, you'll see we have these public events, one for every action in the map. And then the rest of this is just glue code to bind it to the Unity generated C# class. And it's worth noting that there are 3 ways to use the new input system. You can either use Unity events, which have some performance overhead, but there's flexibility of using them, dragging and dropping them via the inspector and serializing them in your scripts. There's messages, which is a little bit lighter weight, but kind of clunky because you're relying on magic strings. And then there's my personal preferred option, and the one that you need to use if you're going to be using NisGab, and that's the generated C# class. This is generally the most performant and most lightweight, and it's the easiest to bind to. That's particularly why we're using it. So you'll see this is the generated input system actions class. This is just all the code that Unity generates for the new input system when you're using C# bindings. So all of this player input actions and the UI input actions classes, all that's doing is just spinning up an instance via this input event class. And this class will always be here. You'll have additional classes for every input action map, but this input event class will always be the same. The only difference is it'll have one instance of each of these, and these are public static instances, so they function as static containers for these public events. So you'll see, if you don't get it now, you'll see in a moment why I have it set up that way. So essentially this input event class is a lazy singleton that spins up this input system actions instance, which is the Unity generated code, and then it binds it to these public static events. So if we mosey on over to the example code, I have this this action map controller class that I wrote, which just wires up some UI buttons. And this is what effectively turns on NisGab. Input event.instance, because I implemented this as a lazy singleton, this is what actually instantiates the singleton. And then because all of the input action maps are going to be off by default, you have to explicitly enable them and disable them when you want them on or off. So here I'm enabling both the player input map as well as the UI input map, and I'm registering to the events. So this is the NisGab syntax for how you want to bind to event. It's input event dot whatever map you're looking into, and then the specific action, and then you subscribe to it just like a regular event. And you can see here, this just matches the signature of the new input system where it has the callback context. So you just register it to it as such. And then I just have this player controller here, which just gives us debug information. So if we go over here to the example scene that I have, There's just some text here to describe the situation, as well as a couple buttons that enable and disable the associated input actions. You're going to see errors like I just had in the console there, because if you have the code uncommented in that example code before you generate, it's going to have a compilation error, obviously, because it's relying on these generated files. So that's why in the package I have it commented out by default. So once you generate the code, make sure you go in those scripts and you uncomment the code in order for this example code, this example scene to work. But let's just double check real quick before we get going. Okay, so I'm going to boot into this scene, and the way you effectively demonstrate this is you can look at the console. So once you see I have UI on click here firing, you're going to get two events, because the way that UI on click works is you get an event for down as well as up. But if I press E, see we're not seeing player input events, but now I'm pressing E, I'm getting player on interact callbacks. Whereas if I toggle UI input, see I'm not getting clicks anymore. The interesting caveat though is that even though I'm not receiving the events via script, the way Unity's UI works is it still allows you to interact with the UI. So that's an interesting caveat. Just make sure if you want to actually prohibit UI interaction, you're going to have to do some fancy stuff with like the canvas raycasters and things like that. So just keep that in mind. Anyway, that's the example. That's the package. I plan on expanding it in the future. Right now, keeping it really lean, keeping it really cheap, just to get going with a project and not having to worry about managing the new input system. Just right click, generate, go, you're good. All right, take it easy.